Welcome back in part 3 of Project Free Jazz. In part 3 we will finally start to make music using the patterns on supercollider. As we've been explaining before, we will do that by generating MIDI events into an external synthesizer. So let's get started. If we want to start talking to an external synthesizer, we will first have to make some kind of connection between supercollider and the synthesizer. And to do that, I will first have to initialize the MIDI client system. So here I check if it's not yet initialized, please initialize it. And if I run this little line of code, you will see what happens in the post window. It prints out all these MIDI sources and MIDI destinations. And it's exactly here you can choose the synthesizer you want to connect to. So if you have a keyboard of your own or a synthesizer of your own, you will probably see other entries here and you will have to use those for your system. In my case, I will be using this Integra 7 and this is what I've used here in this line. Before I'm able to send MIDI data into an external synthesizer, I will have to create a connection between supercollider and the external synthesizer. And to do that, I will have to use the MIDI out object class. But first I have to initialize the MIDI system. And this is what happens here. I check if the MIDI system has been initialized yet. If it's not yet initialized, then I ask the system to initialize it. And if I do that, you will see in the post window that there appears a list of MIDI sources and destinations. And these are exactly the ones that I want to use. So from this list you can choose the synthesizer you want to connect to. If you have a keyboard of your own, then the name for your keyboard should be in this list, and then if it's in the list you can select it and you can use it to talk to it from supercollider. So these are the names that I copied here, and I store the MIDI out instance into a MIDI out variable. Now you may have noticed before that sometimes I use these variables that start with a tilde sign, and sometimes I declare variables with a var at the top of the code block. And there's a difference between the two, which I will explain now. If you declare a variable like this, and you initialize it like this, then by the time the code block ends, the variable is destroyed again. So the MIDI out, by the time we get out of this bracket, it's dead again, it's removed again. However, if we use variables with a tilde, they remain alive, even if we press control point or control period, MIDI out, and I put it in the variable. And from this moment on, I can use it to send notes to my synthesizer. For example, let's play a note on. You should hear something. And then I can switch it off again with the note off command. Of course, this is quite cumbersome if you have to write complete music pieces by scheduling note on and note off messages manually. So here is where also our patterns will help us. So let's first look at a simple pattern in which we make everything random. So I here make a variable random piano and I assign to it an event pattern. And this time I'm using a different type of pattern. I'm putting the key type to MIDI, and this will cause when we turn the pattern into a stream and we start playing that stream, the events that are generated by that stream, if the type is MIDI, then the system knows that it has to generate MIDI signals and send it to an external synthesizer. How does it know which synthesizer to send it to? Well, it gets this as a parameter here. This is the MIDI out that we just initialized. We also have to pass some other data to it. For example, we have to tell the system that the commands that we want to generate are note on commands. We also have to say on which MIDI channel we want to send the commands, and supercollider is a little bit special here because most software counts MIDI channels from channel 1, and supercollider being a programming language, I guess it starts counting from 0. We will see later that, for example, percussion channel is usually on channel 10, MIDI channel 10, but in supercollider that would be channel 9. So you can get very confused if you work with other MIDI software. Keep this in mind. In the pattern I also specify this MIDI note key, and I will use our famous P white by now. P white will generate random numbers between 20 and 100, and it will generate infinitely many, so it will just keep on generating until we manually stop the system. And here I have this very useful method trace, which you can call on any pattern, and this will cause the values that the pattern generates to be dumped into the post window while the pattern is playing. In addition to the MIDI note, I will also set the duration to white noise and also set the amplitude to white noise. So we really have a very random music, and let's have a listen how it sounds like. When you call the play method on a pattern, out comes an event stream player. And so once the pattern is playing, you cannot call stop on the pattern, it won't work, but you can call stop on the player that comes out of the play method. That's just also something that is very confusing for beginners. Like before, I have here my command period class that will execute this code when I press command period or control period on a Windows keyboard, and it will just call all notes off on all MIDI channels for my external synthesizer, which is useful because organ notes, for example, they can get stuck if you just stop the system in the middle while it's playing, and then you don't want that to happen. So let's just listen what we have. We have white noise notes, white noise durations, and white noise amplitudes. What does it sound like? Yeah, that sounds quite avant-garde, if you like, if you want. But it's a bit, there's just one note playing at a time. Maybe we can try to play two of these random piano patterns in parallel, because every time you reinstantiate patterns, they will generate different numbers anyway. If we play two of them in parallel, we should hear two different streams playing at the same time. And the way to play patterns in parallel is by using a new kind of pattern that I probably didn't discuss yet. It's P-par. Par stands for parallel. It takes a list of patterns and it will play all the patterns in the list simultaneously. So let's hear what the difference is. Oh. So now you can hear two notes at the same time, and we can even go further and instantiate three of these patterns in parallel. And what does that sound like? Okay, it sounds like a cat walking over the piano, which is nice, I think. Well, if you like that kind of stuff. But as you can see, the difference between 2 and 3 random pianos playing at the same time is not as big as the difference between 1 and 2, and if you keep adding more, the music does not get any more interesting because of that. So we will have to think about ways to keep our music interesting. And how can we do that? We will have to think, since we do not think in terms of traditional melodies and harmonies in this case, we will have to think of other ways to do that. And so our different properties of our different random number generators that we discussed in the previous part will be very helpful in creating different textures. So we can play not only with the register, so how high or how low the notes that are generated are, but also with the amplitudes, with the durations, to create different look and feel for different patterns. And the combination of all these different textures can be much more interesting than just making everything random all the time. So I've here prepared a slightly different texture, again with piano, and this time we will generate numbers, MIDI numbers again, MIDI notes again, and we will randomly choose from this list. So either we will generate two very random numbers between 20 and 30, or we will generate 3 random numbers between 30 and 60, Or we will generate 4 random numbers between 80 and 95. So these are low notes here. These are low notes, these are middle notes, and these are high notes. Or we will generate rests, because don't underestimate the power of rests in music. If you make everything play all the time, you will get crazy, and rests can really add an extra dimension to your music. Or we will do this, and what does this do? P-Funk we haven't discussed yet, but P-Funk is another type of pattern, and it takes a function. The function will be executed every time a new event is requested. And what does it do? It will flip a coin, and with 70% chance of having heads or 30% chance of having tails. And if it's heads, so with a 70% chance, then we will generate a note between 50 and 60, and we return a list of that generated note and that generated note plus 12. Now, what is the purpose of generating a list of notes in a pattern? If you generate a list of notes in a pattern, it will sound like a chord. And then with a 30% chance, we will return nil from this P-Funk, which causes the P-Funk to stop. If you remember from the previous part of the tutorial, if you return nil from a pattern, it stops. And then it allows the system to choose another random entry from the list here. And this P-Rand will keep on generating notes forever, because we asked here for infinite amount of events to be generated. For the duration, I will now limit myself to a list of metric values. So 1 beat, half a beat, quarter beat, and an eighth of a beat. And we will always select from this list at random and infinitely many. And for the amplitude, I will be using P Brown. If you remember, that was the thing with the step size, that in every step you add or subtract the step size. And we will generate values between 0.4 and 0.9. Amplitude always has to be between 0 and 1, even if in MIDI normally it's between 0 and 127, but supercollider will rescale the values behind the scenes. So let's listen what this sounds like and compare it with what we had before. As you can hear, this is a much less completely random texture than before. We have built in a number of constraints, and in doing so we have actually created our own music theory, if you like. So we now listen to the results of our own music theory, of our own musical universe that we are building. And I think it's very interesting to play with these constraints and embrace the happy accidents, because a lot of times things that work out well are things that were not intended, and you have to be always ready to hear those and to keep them or adjust them, because that's very useful, a very handy way of generating interesting textures. So by all means, go ahead, change everything you see, change all the numbers, add different patterns, play around with it, and you will find wonderful stuff in there. But let's now continue with the tutorial. Slow piano is what we heard, but it's good as one texture, but we need more to have an interesting piece of music, I think. We need a second texture to add to our slow piano, and preferably something that sounds sufficiently different so that we can really hear the difference between the two. If you read about, for example, counterpoint and polyphony, the rules will tell you to avoid parallel fifths and parallel octaves because they threaten the independence of the different melody lines. Here we don't have these rules at all, but here we have to make sure that that our textures are different enough, so that otherwise also the independence between the different textures and patterns is lost, and it adds a lot more to the music if you can still discern between the different patterns that you add. And one way to do so is to use a different instrument, of course, but another way is to really play with your random number generators and change the constraints. So let's first hear the slow piano again. Okay, now let's hear the slow piano and the fast piano together. As you can hear, this is already much more interesting. Because we use this P Brown here in the fast piano, we get a more a kind of bass line, or walking bass if you like, with some imagination at least. I've chosen much shorter durations for the fast piano so that you get more events. Problem now with this, if we play the two together, is that they start at the same time, so there's no build-up in the music. And to have that, we can do something simple here, which is called PT par, which allows us to every time specify a delay between the start of the piece and when the pattern should start playing. So I say slow piano should start immediately, because with a delay of 0, and fast piano should start after 10 beats. So let's hear how that sounds. Slow piano first. And now the fast piano begins. So when you develop all these textures, be sure to play not only with the notes, but also with durations, with amplitude, with things like legato, and there are many more keys you can play with, but I'm not going to discuss those today. But by all means, experiment. There's a lot of wonderful stuff you can make. Okay, so we've had this. Let's continue and add more textures. I will be adding some strings, some brass, and some percussion. And let's just, I will not explain them in complete detail. We just listen to the results. So we will play maybe I should explain this first. We will play the slow piano immediately after start, so with a delay of 0. Then after 10 seconds comes the fast piano texture. Then after 30 seconds from the beginning, so not 30 seconds after this one started, but 30 seconds after the beginning, or not seconds but beats, we start the strings. Then 40 seconds after the player started playing, we start the brass. And together with the brass, we also start percussion. For percussion, I've just used white, P white, so very random. But the durations are always limited to very metric values. And for brass, you will hear it's a kind of funny imitation of how brass can sound in free jazz, I think, at least. First slow piano. Now the fast piano. You can hear the staccato and legato. Some strings. Again with very random notes. And then brass. We've now heard some textures that we could make with the system, and it's time to think about how to start and stop our piece, how to add some structure into it, because most tutorials will stop here with random notes sounding, and well, there's more to music than just random notes, and we can add an extra dimension to our music by adding some structure into the composition. And we will do that in part 4 of the tutorial, so I will be glad if you join me for part 4, where we will also hear the final result of our work.